What if we're not alone in the universe? For centuries, humanity has stared up at the stars, wondering if other worlds out there could cradle life, even civilizations, just like our own. The discovery of exoplanets, those distant worlds orbiting alien suns, has transformed this question from science fiction into a thrilling scientific hunt. And the most astonishing part, we've already found planets so eerily Earth-like they blur the line between imagination and reality. Picture oceans shimmering under crimson skies, mountains towering in low gravity, or even sprawling, uncharted landscapes where the very air might hold the whispers of unknown biology. These aren't scenes from a movie, they're real places scattered across the cosmos, waiting to be explored. Today, we're venturing beyond our solar system to uncover 25 alien planets with conditions so strikingly similar to Earth, they've ignited the imaginations of astronomers and dreamers alike. Some orbit in the perfect Goldilocks zone, where temperatures are just right for liquid water, the essential ingredient for life as we know it. Others boast atmospheres thick with organic molecules or mysterious geological activity that hints at hidden oceans beneath icy shells. Each one is a puzzle piece in the greatest mystery of all. Are we truly alone? Scientists call these worlds potentially habitable, but that term barely scratches the surface of their wonder. From molten lava planets glowing like embers to super-Earths where a single year lasts mere days, these discoveries challenge everything we thought we knew about where life could thrive. This journey isn't just about ticking off a list of distant worlds, it's about stepping into the unknown and redefining what's possible. Every new planet we uncover forces us to ask deeper questions. What would life look like under a triple sunset? Could organisms survive in atmospheres laced with methane instead of oxygen? And if we did find signs of life, how would it change our place in the universe? The answers might be hiding among these 25 extraordinary worlds, each one a testament to the dizzying diversity of our galaxy. So buckle up, we're about to tour the most Earth-like alien planets ever discovered, and by the end, you'll never look at the night sky the same way again. The first stop on our cosmic tour is Kepler 186f, a world that made history as the first Earth-sized planet ever found snugly nestled in the habitable zone of a distant star. Discovered in 2014 by NASA Kepler Space Telescope, this groundbreaking find proved that planets like ours could exist beyond the solar system. Kepler 186f orbits a cool, dim red dwarf star bathing in a perpetual sunset glow. While its sun is smaller and cooler than ours, the planet's position, just the right distance for liquid water to pool on its surface, makes it a tantalizing candidate for life. What makes this world so special? For starters, it's only about 10% larger than Earth, making it one of the most similar in size we've found. A year here lasts just 130 Earth days as it dances close to its star, but not too close. Unlike scorching Venus or frozen Mars, Kepler 186f sits in that sweet spot where temperatures might allow rivers, lakes, or even oceans. Scientists speculate its rocky surface could harbor familiar geology, perhaps even weather systems shaped by that perpetual crimson twilight, yet mysteries abound. Red dwarfs are known for violent flares that could strip away atmospheres, so does this planet hold onto its air? Could any potential life endure the star's tantrums? Some theories suggest that if Kepler 186f has a thick enough atmosphere or a protective magnetic field, life might find a way, just as extremophiles do in Earth's harshest environments. This world doesn't just challenge our assumptions about habitability, it forces us to rethink what life might endure under an alien sun. Its discovery didn't just add another dot on the map of exoplanets. It proved that Earth's twin could be out there, waiting. Kepler 186f's crimson sun reveals both promise and peril in the search for alien life. Red dwarfs, like its host star, are the universe's most common stars, small, cool, and incredibly long-lived, burning for trillions of years. That longevity offers life an unimaginable span to evolve, but these stars come with cosmic hurdles. One major challenge: tidal locking. Just as our moon always shows Earth one face, planets orbiting red dwarfs often become locked, with one side eternally bathed in daylight and the other shrouded in endless night. Imagine a world where scorching deserts melt into frozen wastelands, with only a thin twilight ribbon in between where temperatures might be just right. Yet life could still find refuge, perhaps in subterranean caves shielded from the extremes, or in vast oceanic currents redistributing heat across the planet. Then there's the star's temper. Red dwarfs frequently unleash violent flares, spewing radiation that could scour away atmospheres or sterilize surfaces. But here's the twist: Kepler 186f might have a few tricks to survive. A thick atmosphere, richer in carbon dioxide than Earth's, could act as both a radiation shield and a greenhouse blanket, trapping enough heat to compensate for the star's faint glow. Some models even suggest that a strong magnetic field like Earth's invisible force field could deflect the worst of the stellar storms, and if life did arise here, it might evolve defenses we can barely fathom. Organisms with radiation-resistant biochemistry, or ecosystems thriving deep underwater where liquid layers offer protection. The most tantalizing question remains: could an atmosphere persist at all? Recent studies of similar exoplanets hint that some worlds might regain lost gases through volcanic activity or comet impacts, creating a cycle of destruction and renewal. On Kepler 186f, the balance between these forces, stellar fury versus planetary resilience, could make the difference between a barren rock and a living world. While we don't yet have the tools to confirm its atmosphere, this planet stands as a testament to nature's adaptability. It challenges us to expand our definition of habitable and reminds us that life, if it exists out there, might flourish in ways we've never dreamed. This isn't just about one world. Kepler 186f represents a cosmic laboratory, testing the limits of where life could take root. Every red dwarf planet we discover forces us to rethink the rules, and with hundreds of billions of these stars in our galaxy alone, the possibilities are staggering. Just a cosmic stone's throw away from Earth, a mere 4.24 light-years, lies a world that could rewrite our understanding of nearby habitable planets. Proxima Centauri b isn't just another exoplanet. It's our next-door neighbor in the vast expanse of space, orbiting the closest star to our Sun. Discovered in 2016, this rocky world sent shockwaves through the astronomy community, not just for its proximity, but for its tantalizing position in the habitable zone of its star, Proxima Centauri. Here, temperatures could allow liquid water to exist, but this planet is anything but a tranquil Earth twin. Proxima Centauri b races around its tiny, tempestuous star in just 11 Earth days, so close that its year flashes by in less than 2 of our weeks. Its sun, a red dwarf like Kepler 186f's, is a stormy beast, frequently erupting with flares hundreds of times more powerful than anything our Sun produces. These violent outbursts blast the planet with enough radiation to strip away atmospheres and scorch surfaces, raising a critical question: could any environment here withstand such fury? Yet despite the chaos, hope persists. Models suggest Proxima Centauri b might cling to a thick, protective atmosphere, or even harbor a global ocean beneath an icy shell, a scenario where life could thrive shielded from the storms above. The excitement around this world isn't just scientific, it's logistical. Its staggering closeness makes it the prime target for humanity's first interstellar missions. Projects like Breakthrough Starshot aim to send tiny, laser-propelled probes hurtling toward Proxima Centauri b within decades, potentially beaming back our first close-up data of an alien world. Imagine photographs of another planet's landscapes or sensors detecting chemical signatures of life, all from a place close enough that a radio signal could reach it in just over 4 years. But the mysteries run deep. Is Proxima Centauri be tidally locked, with one side eternally scorched and the other frozen? Could its atmosphere, if it exists, redistribute heat enough to create habitable pockets? And if life did emerge here, what bizarre adaptations might it have developed to survive the relentless radiation? Every new study peels back another layer of possibility, reminding us that the most Earth-like worlds might not look like Earth at all. Proxima Centauri b isn't just a destination, it's a challenge to our imagination, proving that the universe hides its greatest secrets right on our cosmic doorstep. The Breakthrough Starshot initiative sounds like something ripped from the pages of science fiction, but this daring project could become humanity's first real attempt to reach another star. Imagine spacecraft so small they fit in your hand, equipped with gossamer-thin light sails, hurtling toward Proxima Centauri b at 20% the speed of light. These nanoprobes, weighing little more than a paperclip, would rely on an Earth-based array of powerful lasers to propel them across the void, turning a journey that would take conventional rockets tens of thousands of years into a mere 20-year sprint. At the heart of this audacious plan lies the light sail, a revolutionary propulsion method that ditches bulky fuel tanks for the pure power of photons. Picture a sail thinner than a human hair, stretching several meters wide but weighing almost nothing. When targeted by focused laser beams, the photon's momentum pushes the sail forward, accelerating these tiny probes to velocities previously unimaginable for human-made objects. It's like the solar sails scientists have tested before, but supercharged, using concentrated light instead of scattered sunlight to achieve speeds that could finally make interstellar travel feasible. Yet the challenges are as staggering as the ambition. Even at 20% light speed, these probes would need to survive decades of exposure to cosmic radiation, microscopic space debris, and the unforgiving vacuum of interstellar space. Then there's the precision required. The laser array would need to focus on the sails with pinpoint accuracy over billions of miles, adjusting for any drift as the probes race away from Earth. And if they do reach Proxima Centauri b, how would they send data back? Each nanoprobe would carry a miniature communications system, but transmitting even a single image across 4.24 light-years would require breakthroughs in laser technology we're only beginning to explore. But the payoff could redefine science itself. Imagine high-resolution images of Proxima Centauri b's terrain, atmospheric analyzers detecting water vapor or organic compounds, even potential biosignatures hinting at life. Unlike telescopes that study exoplanets as distant specks of light, these probes would offer an up-close look at another world's geology, weather, and chemistry. They might answer whether the planet has oceans beneath its ice, active volcanoes, or even surface features shaped by unknown forces. For astrobiologists, it's the holy grail direct evidence of whether life exists beyond our solar system. The Starshot initiative isn't just about reaching a planet, it's about redefining what's possible. Successful or not, the attempt alone pushes the boundaries of engineering, material science, and astrophysics, forcing us to solve problems we've never faced. And if it works, Proxima Centauri b could become the first exoplanet humanity truly knows, transforming it from a blur in our telescopes to a place with mountains, skies, and perhaps even shorelines we can name. That's the power of this mission, not just to glimpse another world, but to bring it within reach. From the nearest star to one of the most intriguing planetary systems ever discovered, TRAPPIST-1e is a world that shatters expectations. Nestled 39 light-years away in the constellation Aquarius, this Earth-sized planet orbits an ultra-cool red dwarf star alongside 6 sibling worlds, forming a cosmic family so tightly packed they'd all fit inside Mercury's orbit around our Sun. But TRAPPIST-1e isn't just another exoplanet lost in the crowd. Of the system's 7 known planets, it's the crown jewel, positioned perfectly in the habitable zone where liquid water could pool on its surface. What makes this world so special? For starters, its size almost identical to Earth's, with a radius just 6% smaller. That similarity extends to density, suggesting a rocky composition with potential plate tectonics or volcanic activity. But the real magic lies in its orbit. While TRAPPIST-1e completes a full journey around its star in just 6 Earth days, its proximity to the dim red dwarf places it in that sweet spot, neither too hot nor too cold for water to exist as a liquid. Scientists have even modeled its possible climates, revealing scenarios where stable oceans could cling to its surface, or thick atmospheres might redistribute heat efficiently enough to prevent the tidal locking that plagues other red dwarf planets. The TRAPPIST-1 system itself is a marvel of cosmic architecture. All 7 planets dance in an intricate gravitational harmony, their orbits so precisely spaced they influence each other's movements in ways detectable from Earth. This rare configuration allowed astronomers to calculate each world's mass and density with unprecedented accuracy, and TRAPPIST-1e's numbers hint at tantalizing possibilities. Unlike gassy giants or barren rocks, its composition suggests it could harbor both land and water, with a gravity close enough to Earth's that walking there might feel strangely familiar. Yet mysteries loom. Red dwarfs like TRAPPIST-1 are notorious for their violent flares, and without a protective magnetic field, this planet's atmosphere could have been stripped away eons ago. But recent studies offer hope. Some models show that TRAPPIST-1e might have held onto its air, or even regenerated it through volcanic outgassing. Others speculate that its potential oceans, if they exist, could be rich in minerals, creating a brine so concentrated it resists freezing even in the star's faint light. The most exciting clue: TRAPPIST-1e sits in what scientists call the optimistic habitable zone, a region where conditions might support not just microbial life, but complex organisms. While we can't yet peer through its atmosphere, future telescopes like the James Webb Space Telescope could analyze starlight filtering past its skies, searching for telltale molecules like oxygen or methane. Finding them would revolutionize our understanding of life's cosmic odds. This isn't just a planet, it's a test case for how common Earth-like worlds might be. With 7 planets in one system, 3 of them in the habitable zone, TRAPPIST-1 challenges the old assumption that life requires a sunny, solitary world like ours. Maybe life thrives in packed planetary neighborhoods under dim red suns we once ignored. Every new discovery here forces us to rethink the rules and wonder what might be waiting in those alien tides. Deep in the constellation Cetus, 49 light-years from Earth, a super-Earth named LHS 1140b defies the odds. Unlike the chaotic environments of many red dwarf planets, this world orbits an unusually quiet star, one that rarely flares, offering its planetary companion a rare gift: stability. With a mass nearly 7 times Earth's and a thick, possibly water-rich atmosphere, LHS 1140b stands out as one of the most promising candidates for habitability beyond our solar system. What sets this planet apart is its atmosphere, dense and likely blanketed in gases that could trap heat efficiently. While its surface gravity would feel crushing to humans, that very density might be the key to preserving liquid water. Models suggest the planet could host a global ocean, its depth and pressure creating conditions where life might thrive even under the dim glow of its red dwarf sun. Unlike Proxima Centauri b or TRAPPIST-1e, where violent stellar flares threaten to strip away atmospheres, LHS 1140b's tranquil star raises the tantalizing possibility that its air and oceans have endured for billions of years. Scientists are particularly intrigued by the planet's potential biosignatures. Recent observations using the James Webb Space Telescope have aimed to analyze the chemical composition of its atmosphere, searching for molecules like oxygen, methane, or even dimethyl sulfide, a compound on Earth produced only by living organisms. The quiet nature of its star makes these observations cleaner, without the interference of frequent stellar eruptions that muddy data from other red dwarf systems. But LHS 1140b isn't just a passive recipient of its star's benevolence. Its hefty size suggests active geology, perhaps volcanic outgassing replenishing its atmosphere or hydrothermal vents churning in its oceans, much like those on Earth where life clusters in the darkest depths. Some researchers speculate it could be a Hycean world, a theorized class of planets with hydrogen-rich atmospheres overlying vast liquid water layers. If so, its alien seas might be nothing like ours, with chemistry so exotic it challenges our very definition of habitability. The quiet resilience of this super-Earth offers something rare in the hunt for habitable worlds: time. While other planets battle hostile stars or extreme climates, LHS 1140b's steady environment suggests it could have maintained stable conditions long enough for life to emerge and persist. It's a reminder that habitability isn't just about location but endurance. Every new study of this world peels back another layer, revealing not just how strange alien planets can be, but how strangely familiar they might become. Among the thousands of exoplanets discovered so far, Kepler 442b shines as one of the most promising Earth twins we've ever found. Located over 1,100 light-years away in the constellation Lyra, this rocky world boasts an Earth similarity index of 0.84, a staggering score that places it among the top contenders for habitability beyond our solar system. Unlike the volatile red dwarf systems we've explored so far, Kepler 442b orbits a calmer, more stable K-type star, bathing in golden light that might feel eerily familiar to any Earthling. What sets this planet apart is its balance of conditions. Slightly larger than Earth at 1.3 times our planet's radius, it's likely rocky with enough gravity to hold onto a substantial atmosphere. Its orbit lasts 112 Earth days, placing it squarely in the habitable zone where liquid water could exist. But here's the twist. Its star, though dimmer than our Sun, emits a gentler, more consistent light, avoiding the violent flares that threaten planets around red dwarfs. That stability means Kepler 442b could have maintained a temperate climate for billions of years, giving life time to emerge and evolve. The planet's potential for photosynthesis adds another layer of intrigue. K-type stars emit enough light in the right wavelengths to fuel plant-like organisms, but without the harmful ultraviolet radiation that bombards worlds orbiting younger, hotter stars. Imagine alien forests basking in perpetual golden hour, their leaves adapted to capture energy from this mellower sun. Scientists speculate that if Kepler 442b has continents and oceans, its climates could be less extreme than Earth's. No scorching deserts or frozen tundras, just vast, temperate belts where life might thrive with ease. Yet studying this world comes with immense challenges. At over 1,000 light-years away, even our most advanced telescopes struggle to glimpse more than its size and orbit. Confirming an atmosphere or surface water requires detecting subtle changes in starlight as it filters through the planet's air, a task like spotting a firefly's glow next to a spotlight. Future observatories, like the planned Habitable Worlds Observatory, might finally reveal whether Kepler 442b has skies filled with clouds or oceans reflecting sunlight. Until then, it remains a tantalizing mystery, a world so statistically similar to ours, it's impossible not to wonder what secrets its golden shores might hold. The very existence of Kepler 442b challenges our assumptions about where life could flourish. K-type stars, often overlooked in favor of Sun-like G-types, might actually offer the perfect compromise, long-lived stability without the temperamental outbursts of red dwarfs. With lifespans stretching tens of billions of years, they provide habitats where evolution could unfold at a leisurely pace, perhaps nurturing civilizations that last far longer than humanity's brief flicker so far. This planet isn't just a scientific curiosity, it's a beacon, reminding us that Earth's twin might not circle a star like ours at all. Hidden in the constellation Aries, just 12 light-years from Earth, lies a world that could rewrite the rules of habitability. Tegodon Star B. Unlike the violent red dwarfs we've encountered, this planet orbits an ultra-cool dwarf star so faint it wasn't even discovered until 2003. Yet despite its star's dim glow, Tegodon Star B has astronomers buzzing with excitement. Why? It's one of the most Earth-like planets we've ever found, not just in size but in potential climate. With a mass almost identical to Earth's, this rocky world nestles perfectly within its star's habitable zone. But here's where things get fascinating. Tegodon Star is a cosmic anomaly, small, ancient, and remarkably stable. While most red dwarfs rage with flares, this one simmers quietly, offering its planets a rare gift: consistency. Models suggest Tegodon Star B could maintain surface temperatures averaging around 28 degrees Fahrenheit, chilly by Earth standards, but warm enough for liquid water if it has even a modest greenhouse atmosphere. Picture a world where glaciers give way to temperate valleys, or where underground geothermal heat creates oases like pockets shielded from the cold. The star's age adds another layer of intrigue. Estimated at 8 billion years old, nearly twice the Sun's age, this system has had an eternity for life to emerge and evolve. That longevity raises thrilling questions. Could life here have endured long enough to develop intelligence? Would organisms in such an ancient world have biochemical adaptations we can't even imagine? The sheer timescales involved are staggering. If complex life exists here, it might predate Earth's earliest multicellular organisms by billions of years. Yet mysteries loom. Ultra-cool dwarfs like Tegodon Star emit mostly infrared light, meaning any potential plants would need to harness energy from wavelengths invisible to our eyes. And while tidal locking is likely, the planet's thick atmosphere, if it exists, could distribute heat more evenly than we see on similar worlds. Recent studies even suggest Tegodon Star B might have avoided the atmospheric stripping that plagues other red dwarf planets thanks to its star's gentle nature. What makes this discovery so pivotal isn't just the planet itself, it's what it represents. Tegodon Star B proves that Earth mass worlds can form around the universe's smallest, dimmest stars, expanding the cosmic real estate where life might thrive. With hundreds of billions of these ultra-cool dwarfs in our galaxy alone, the implications are staggering. The most common stars in the universe might also be the most likely to host habitable worlds. This isn't just another exoplanet, it's a glimpse into a shadowy, ancient ecosystem that could be far more widespread than we ever dared hope. Breaking all expectations, K2-18b stands as one of the most groundbreaking exoplanet discoveries in modern astronomy, not for being Earth's twin, but for shattering our assumptions about where life could exist. Orbiting a faint red dwarf star 110 light-years away, this enigmatic world made history when the Hubble Space Telescope detected something unprecedented in its atmosphere: water vapor. Not just traces, but significant amounts, marking the first time we've confirmed this life-giving molecule in the skies of a habitable zone planet beyond our solar system. But K2-18b defies simple categorization. Is it a super-Earth or a mini-Neptune? With a mass 8 times greater than our planet and a radius 2.6 times larger, it straddles the line between rocky behemoth and gassy dwarf. This ambiguity fuels fierce debate. Some models suggest a rocky core swathed in a thick hydrogen-rich atmosphere where pressures are so intense, water exists not as oceans but as superheated steam or even exotic high-pressure ice. Others propose a more tantalizing scenario: a true water world, its entire surface buried beneath a global ocean dozens of miles deep, capped by a steamy, humid sky. The implications are staggering. If K2-18b does harbor liquid water, it wouldn't look like anything on Earth. Picture an abyss without land, where the ocean floor isn't rock but a layer of compressed ice forming a barrier between liquid and the planet's molten core. In such an environment, life wouldn't need shores. It could flourish in perpetual buoyancy, suspended in endless waters rich with minerals churned up from below. What makes this discovery even more extraordinary is how it reshapes the search for habitable worlds. Before K2-18b, astronomers focused on Earth-sized planets, assuming gas-enveloped worlds were inhospitable. But here's the twist: that thick hydrogen atmosphere might actually act as a protective blanket. SHIELD-ING Chinese letter OCEANS from the ravages of space radiation, while trapping enough heat to maintain liquid water despite the star's faint glow. Suddenly, the habitable zone expands to include planets we once dismissed. Future observations could settle the debate. The James Webb Space Telescope has already trained its mirrors on K2-18b, analyzing atmospheric chemistry for signs like methane or ammonia molecules that could hint at geological activity or even biological processes. Each new data point peels back another layer of this world's mysteries, forcing us to confront an exhilarating possibility. The universe might be teeming with life, not just on planets like ours, but in places we're only beginning to imagine. K2-18b isn't just a scientific curiosity, it's a portal to a stranger, wetter cosmos, where the rules of habitability are being rewritten before our eyes. Haitian worlds represent one of the most radical shifts in our hunt for habitable planets' environments so alien. They challenge everything we thought we knew about where life could thrive. Picture a planet where the skies are thick with hydrogen, the air pressure crushing, and the surface buried beneath an ocean so vast it makes Earth's seas look like puddles. These aren't science fiction fantasies. They're Haitian planets, a groundbreaking class of exoplanets first theorized in 2021, with K2-18b as their most famous real-world example. What makes these worlds so extraordinary is their chemistry. Unlike Earth's nitrogen-oxygen atmosphere, Haitians are shrouded in dense hydrogen envelopes which act like cosmic pressure cookers. At first glance, that sounds inhospitable, but here's the twist. That very hydrogen blanket could trap enough heat to maintain liquid oceans, even under the faint glow of a red dwarf star. And beneath those crushing skies, something remarkable might be happening. The oceans of a Haitian planet wouldn't be just water. They'd be laced with organic molecules, salts, and minerals, creating a primordial soup where life's building blocks could assemble in ways we're only beginning to understand. K2-18b fits this model perfectly. Recent data from the James Webb Space Telescope revealed not just water vapor in its atmosphere, but also methane and carbon dioxide chemicals that, on Earth, often hint at biological activity. Of course, those molecules could have non-living origins too, but their presence is tantalizing. Imagine a planet where methane-producing microbes thrive in the dark depths, or where exotic organisms harness chemical energy from hydrothermal vents, much like Earth's extremophiles do near underwater volcanoes. The sheer scale of these oceans adds another layer of possibility. With depths potentially reaching hundreds of miles, Haitian planets could host ecosystems stacked in layers, each zone home to life forms adapted to specific pressures, temperatures, and chemistries. Yet the challenges are as stark as the opportunities. The crushing pressure and hydrogen-rich air would be lethal to Earth-like life, but that doesn't mean life is impossible, just different. Organisms here might rely on enzymes we've never seen, or metabolic pathways that function without oxygen. Some scientists even speculate that Haitian microbes could float in the upper layers of the ocean, feeding on organic molecules raining down from chemical reactions in the atmosphere. It's a world where biology, if it exists, would operate on rules we're only starting to decode. The hunt for answers is heating up. JWST has already scheduled follow-up observations of K2-18b, aiming to detect dimethyl sulfide, a compound on Earth produced almost exclusively by phytoplankton. Finding it in the atmosphere of a Hycean world would be the closest thing to a smoking gun for alien life we've ever seen. Meanwhile, astronomers are scouring data for other Hycean candidates, realizing these planets might be far more common than we ever imagined. Hycean worlds force us to rethink the boundaries of life. If organisms can thrive under such extreme conditions, the universe might be teeming with habitats we once dismissed as barren. K2-18b isn't just a scientific curiosity, it's a beacon, illuminating a path to discoveries that could redefine our place in the cosmos. The deeper we look, the clearer it becomes. Life, if it's out there, might be far stranger and far more resilient than we ever dreamed. JJ357d sits in the constellation Hydra, 31 light-years from Earth. A stone's throw in cosmic terms, yet its conditions push the boundaries of what we consider habitable. Discovered in 2019 by NASA test mission, this super-Earth stunned astronomers with a paradox: a world cold enough to freeze the air out of your lungs, but possibly warm enough to cradle life beneath a thick, insulating atmosphere. With a mass at least 6 times Earth's and a year lasting just 55.7 days, it orbits a quiet M-dwarf star so faint you could stare right at it without blinking. What makes this planet so compelling is its delicate balancing act. Nestled at the outer edge of its star's habitable zone, JJ357d receives only about a third of the stellar energy Earth gets from the Sun. Surface temperatures could plummet to -64°F, inhospitable by our standards, but with a twist. If this world has a dense carbon dioxide atmosphere, something remarkable happens. Like a planetary greenhouse, those gases could trap just enough heat to create pockets of liquid water beneath ice sheets or in deep, sheltered valleys. Imagine a landscape where glaciers scrape across volcanic plains, hiding underground lakes warmed by geothermal vents, a scenario reminiscent of Antarctica's dry valleys where life clings on against all odds. The star's tranquility plays a crucial role. Unlike flare-prone red dwarfs that bombard their planets with radiation, JJ357's Sun is a quiet neighbor emitting steady, gentle light. This stability means any atmosphere here might have persisted for billions of years, undisturbed by stellar tantrums. Scientists speculate that with enough atmospheric pressure, even the planet's dark side, locked in perpetual twilight due to tidal forces, could maintain temperatures above freezing, creating a narrow band where life might huddle. The discovery of JJ357d forced a radical rethink. Habitability isn't just about temperature, it's about resilience. If microbes can thrive in Earth's permafrost or hydrothermal vents, why not here? Future telescopes could scan its atmosphere for biosignatures like methane or nitrous oxide, gases often linked to biological activity, but the real lesson lies deeper. JJ357d proves that even on the frozen fringes of habitability, nature finds a way. It's a reminder that life, if it exists out there, might flourish in the last places we'd think to look. 1,200 light-years from Earth, shrouded in the constellation Lyra, Kepler 62f emerges as one of the most compelling Earth analogues ever discovered. This mysterious world, slightly larger than our own at 1.4 times Earth's radius, orbits on the outer fringes of its star's habitable zone, a region where temperatures might allow liquid water to exist, but with a twist. While its sun is smaller and cooler than ours, Kepler 62f basks in just enough warmth to avoid freezing solid, yet remains distant enough to escape a runaway greenhouse effect. What makes this planet so intriguing is its longevity. Unlike younger, volatile stars, Kepler 62 has burned steadily for billions of years, offering its planets a rare gift: time. Models suggest Kepler 62f could have maintained stable conditions for most of its 7 billion-year lifespan, an eternity compared to Earth's 4.5 billion years. Imagine a world where evolution unfolded across epochs we can scarcely comprehend. where life might have had triple the time to develop intelligence or complexity. Yet studying this distant gem comes with immense challenges. At over 1,000 light-years away, even our most advanced telescopes struggle to glimpse more than its orbital period and approximate size. Confirming an atmosphere or surface features would require detecting infinitesimal dips in starlight as the planet transits its star, a feat like spotting a single grain of sand on a beach from orbit. The James Webb Space Telescope has attempted to analyze its atmosphere, but so far the data remains frustratingly faint, obscured by the vast interstellar distance. Kepler 62f isn't alone in its system. It shares its sun with 4 siblings, including Kepler 62e, a warmer, closer world that might be a water-covered super-Earth. The contrast between these two planets is striking. While 62e hugs its star tightly, likely roasting under a thick steam atmosphere, 62f's more leisurely orbit places it in a cooler, potentially more balanced climate zone. Together, they showcase the staggering diversity of habitable environments, one a sweltering ocean world, the other a colder but potentially more Earth-like candidate. The true fascination lies in Kepler 62f's potential landscapes. If it has retained a thick carbon dioxide atmosphere, the greenhouse effect could trap just enough heat to prevent global glaciation. Picture a world where sprawling ice sheets give way to temperate coastal belts, or where geothermal hotspots create oases of liquid water beneath frozen surfaces. Some simulations even suggest its slow rotation, tidally locked or not, might generate powerful jet streams, redistributing heat more evenly than we see on Earth. What's undeniable is how this planet reshapes our cosmic perspective. Kepler 62f proves that Earth-sized worlds can thrive far from their star's warmth, clinging to habitability through atmospheric chemistry rather than stellar proximity. It's a reminder that life, if it exists, might flourish in the unlikeliest of places, not just in Goldilocks zones, but in the silent, frozen fringes where patience and persistence could nurture wonders we've yet to imagine. Just 14 light-years away, practically our cosmic backyard, lies a world that could rewrite the rules for nearby habitable planets. Wolf 1061c isn't just another exoplanet. It's one of the closest super-Earths ever discovered, orbiting a quiet red dwarf star in the constellation Ophiuchus. What makes this world so extraordinary isn't just its proximity to Earth, but its delicate dance along the inner edge of its star's habitable zone. Unlike many red dwarf planets that cling to the outer fringes where warmth is scarce, Wolf 1061c basks in a region where liquid water could pool on its surface if it strikes the right atmospheric balance. This super-Earth, about 4 times the mass of our planet, presents a tantalizing paradox. Its tight orbit, just 18 Earth days, might suggest a scorched wasteland, but the star's faint glow means temperatures could be surprisingly mild. Models suggest that with a reflective cloud cover or a moderate greenhouse atmosphere, Wolf 1061c might avoid the extremes of boiling oceans or frozen deserts. Instead, it could maintain a stable, Earth-like climate where conditions stay just right for millennia. The planet's size adds another layer of intrigue. Its stronger gravity could help retain a thick atmosphere, while its likely rocky composition hints at active geology, perhaps even plate tectonics recycling gases and regulating temperatures over eons. Yet mysteries loom. Red dwarfs like Wolf 1061 are notorious for their mood swings, and while this star is relatively calm compared to flare-prone siblings, it's not entirely docile. Even occasional stellar eruptions could strip away the planet's atmosphere over time unless, like Earth, it has a magnetic field acting as an invisible shield. Recent observations have tried to detect traces of an atmosphere using starlight filtering through its skies, but so far the results remain elusive. The James Webb Space Telescope could soon change that, analyzing infrared signals for molecules like water vapor or carbon dioxide that might hint at habitable conditions. What truly sets Wolf 1061c apart is its location in the cosmic neighborhood. 14 light-years is close enough that future telescopes might one day map its surface features or even detect city lights if any exist. Projects like Breakthrough Starshot have already eyed this system as a potential destination for interstellar probes, making it not just a scientific curiosity, but a tangible target for exploration. The idea that a world like this, so near, so Earth-like in potential, could host life forces us to confront a thrilling possibility. The universe might not just be teeming with habitable planets. They could be right next door. Kepler 452b isn't just another exoplanet, it's the closest thing we've found to Earth's long-lost cousin. Located 1,400 light-years away in the constellation Cygnus, this world orbits a star eerily similar to our Sun, a yellow G-type dwarf with nearly the same temperature and brightness. But what truly sets Kepler 452b apart is its uncanny resemblance to our own planet. With a diameter just 10% larger than Earth's and an orbital period of 385 days, it basks in sunlight almost identical to ours, positioned perfectly in the habitable zone where water could flow freely. If you stood on its surface, the sun in the sky might look unsettlingly familiar, just slightly older and dimmer, yet this kinship comes with a twist. Kepler 452b star is 6 billion years old, 1.5 billion years senior to our Sun, making the planet itself far more ancient than Earth. That staggering age raises profound questions. If life emerged here, it would have had an extra billion years to evolve beyond anything we recognize. Imagine civilizations rising and falling across epochs longer than all of human history, or organisms adapting to slow changes in their aging sun's light. While we can't yet detect signs of life at such distances, the mere possibility forces us to confront how brief and fragile humanity's story might be in cosmic terms. The planet's potential landscapes add another layer of fascination. Models suggest it could be a rocky world with active volcanoes, mountain ranges sculpted by eons of erosion, and vast oceans reflecting its golden sunlight. But there's a catch. As stars age, they grow brighter, and Kepler 452b's sun may have already crossed a threshold. Some scientists speculate the planet could be experiencing a runaway greenhouse effect, its once temperate oceans boiling away under the star's increasing glare. If so, it might resemble Venus's fate, a cautionary tale of what Earth could one day become. Confirming these theories, however, remains a monumental challenge. At 1,400 light-years away, even our most advanced telescopes struggle to glimpse more than Kepler 452b's shadow as it crosses its star. Detecting an atmosphere, let alone surface features, requires analyzing starlight filtered through layers of gas thinner than a single pixel in our instruments. Future observatories like the Habitable Worlds Observatory might change that, searching for chemical signatures like oxygen or methane that could hint at biological activity. Until then, Kepler 452b stands as both a mirror and a mystery, a world so similar to ours in size and setting, yet separated by time and distance so vast, it might as well be a message in a bottle from the distant past. Its discovery reshaped our cosmic perspective. Before Kepler 452b, astronomers wondered if Earth-like worlds around Sun-like stars were rare. Now we know they exist, and if this one orbits a star 6 billion years old, how many others might be out there, younger or older, at different stages of their habitable windows? The universe doesn't just offer snapshots of alien worlds, it gives us time lapses showing how planets evolve over billions of years. Kepler 452b isn't just a place. It's a glimpse into Earth's possible future and a reminder that life, if it exists beyond our solar system, might thrive in eras we can scarcely comprehend. Ross 128b whispers a tantalizing possibility, a world where silence might be the key to life. Orbiting a red dwarf star just 11 light-years from Earth, This exoplanet stands apart from its volatile siblings because of its star's remarkable calm. Unlike the flare-prone red dwarfs that blast their planets with radiation, Ross 128 simmers quietly, offering its planetary companion something rare: peace. That stability makes Ross 128b one of the most promising candidates for habitability in our cosmic neighborhood. With a mass only 1.35 times Earth's, this planet fits snugly into the category of rocky super-Earths, likely boasting a solid surface with mountains, valleys, and perhaps even bodies of water. Its orbit lasts a mere 9.9 Earth days, but because its star is so dim and cool, Ross 128b basks in temperatures that could allow liquid water to exist if it has the right atmospheric conditions. Scientists estimate its equilibrium temperature hovers around -76 degrees Fahrenheit, but that's just the starting point. A thick atmosphere with greenhouse gases like carbon dioxide could trap enough heat to create temperate pockets, especially if tidal forces keep one side forever facing the star, creating a twilight zone where conditions might be just right. What truly sets this world apart is its star's unusual placidity. Most red dwarfs are notorious for their violent outbursts, but Ross 128 emits almost no flares, a trait that significantly boosts the chances its planet has held onto an atmosphere over billions of years. Without constant stellar tantrums stripping away its air, Ross 128b could have maintained stable conditions long enough for life to emerge and evolve. That stability also makes it a prime target for astronomers hunting biosignatures. Unlike more active stars where flares muddy atmospheric observations, Ross 128's steady light offers a clean signal, making it easier to detect molecules like oxygen, methane, or even signs of photosynthetic pigments in its skies. Future telescopes are already setting their sights on this quiet world. The James Webb Space Telescope could soon analyze its atmosphere for chemical fingerprints, while next-generation observatories like the Extremely Large Telescope might one day map its surface thermal emissions, searching for contrasts between day and night sides that could hint at oceans or continents. The proximity of Ross 128b adds another layer of excitement. At just 11 light-years away, it's close enough that targeted radio surveys have even listened for artificial signals, just in case a civilization has flourished under that gentle red sun. Yet mysteries linger. Is the planet tidally locked with one side scorched and the other frozen? Or does a thick atmosphere redistribute heat, creating a habitable ribbon along the terminator line? Could underground aquifers or geothermal vents provide refuge even if the surface proves harsh? Every new observation peels back another layer, revealing not just the secrets of this world, but the broader question: does silence in the cosmos favor life? Ross 128b doesn't shout its potential, it hums it, inviting us to lean closer and listen. The implications stretch far beyond a single planet. If tranquil red dwarfs like Ross 128 commonly host habitable worlds, the galaxy could be filled with oases where life unfolds undisturbed by stellar chaos. This isn't just about finding another Earth, it's about discovering how many different ways a planet can whisper back to the universe that it's alive. HD 40307G challenges our assumptions about what makes a planet truly Earth-like. Orbiting a K-type star 42 light-years away in the constellation Pictor, this super-Earth is nearly 7 times more massive than our home planet, yet it occupies the sweet spot in its star's habitable zone where liquid water could exist. What makes this world so intriguing isn't just its position. It's the delicate interplay of factors that could turn it into either a temperate paradise or a suffocating greenhouse. Unlike the turbulent red dwarfs that dominate our catalogue of potentially habitable worlds, HD 40307G's Sun offers a gentler environment. K-type stars burn steadily for tens of billions of years, outliving our Sun by magnitudes. This stability gives planets like HD 40307G something priceless: time. With an orbital period of 197 Earth days, it basks in sunlight only slightly dimmer than ours, raising the possibility of a climate where seasons unfold in a rhythm not too alien from Earth's. But mass complicates the picture. A planet this hefty likely boasts a crushing gravity double Earth's, which could help it retain a dense atmosphere rich in greenhouse gases like carbon dioxide. Some models suggest that thick shroud might act as a thermal blanket, trapping just enough heat to compensate for the star's weaker glow. Picture towering mountain ranges weighed down by intense gravity, beneath skies tinged orange from atmospheric scattering, where storms brew in slow motion under the pull of that relentless G-force. The real mystery, though, lies in its rotation. Early observations hinted HD 40307G might be tidally locked, forever showing one face to its star. But recent studies propose a tantalizing alternative, a resonant rotation like Mercury's, where the planet spins 3 times for every 2 orbits. This would create a day-night cycle utterly alien to Earth, a world where the sun crawls backward across the sky and seasons blur into a kaleidoscope of uneven light and shadow. Such a rhythm could distribute heat more evenly than a locked rotation, potentially fostering stable climates where life could adapt to the strange cadence of its sun. Debates rage about this planet's true nature. Could its atmosphere be so thick it creates a Venus-like inferno? Or does it strike a perfect balance, with high-altitude clouds reflecting excess heat and deep oceans sequestering carbon? The answer might lie in the star's composition. K-type stars emit less harmful ultraviolet radiation than their hotter cousins, reducing the risk of atmospheric erosion, a critical advantage for preserving habitable conditions over billions of years. Every new observation of HD 40307G peels back another layer of possibility. It's a reminder that habitability isn't just about size or orbit. It's a fragile equation of gravity, chemistry, and motion. In this distant world's skies, we might one day find the fingerprints of an atmosphere that defies our expectations, proving yet again that the universe writes its rules in ways we're only beginning to decipher. JJ667cc isn't just another exoplanet, it's a cosmic puzzle wrapped in a triple star enigma. Located 22 light-years away in the constellation Scorpius, this rocky super-Earth orbits within the habitable zone of its red dwarf sun, JJ667c. But here's the twist: that star isn't alone. It's locked in a gravitational dance with 2 companion stars, a pair of orange dwarfs creating a celestial ballet where 3 suns light up the skies of this distant world. Under their combined glow, JJ667cc emerges as one of the most Earth-like planets we've ever found, with an Earth similarity index of 0.85, a score rivaling even the most promising habitable zone candidates. What makes this planet so fascinating is its delicate balance of forces. Weighing in at nearly 4 times Earth's mass, JJ667cc likely boasts a robust gravity strong enough to hold onto a thick atmosphere, yet not so crushing it would stifle the possibility of surface oceans. Its orbit lasts just 28 Earth days, but because its primary star is so faint, the planet basks in sunlight comparable to what Earth receives, raising the tantalizing prospect of liquid water pooling across its surface. Yet the presence of 2 additional suns complicates the picture. While those stars orbit farther out, their gravitational tugs could stir JJ667cc's interior, generating tidal heating that might fuel volcanic activity or even subsurface oceans akin to Jupiter's moon Europa. The tidal forces at play here could be both a blessing and a curse. On one hand, this internal warmth might prevent global glaciation, maintaining pockets of liquid water even if the planet's surface freezes. On the other, excessive heating could trigger runaway volcanism, turning JJ667cc into a molten hellscape with atmospheres choked by ash. The key lies in the balance, enough heat to sustain geology, but not so much it destabilizes the climate. Studying this world, however, is like trying to eavesdrop on a whispered conversation across a crowded room. The triple star system creates a shimmering haze of light that makes it incredibly difficult to isolate JJ667cc's signal. Astronomers have had to rely on radial velocity measurements detecting the faint wobble of its star as the planet tugs on it rather than the more straightforward transit method used for other exoplanets. This complexity means we still don't know if JJ667cc has an atmosphere, let alone whether it's rich in oxygen or carbon dioxide. Yet the glimpses we do have are electrifying. Spectral analyses suggest the planet's star is unusually metal-poor, meaning it formed from primordial gas largely untouched by the heavier elements forged in stellar explosions. This raises a provocative question: could life arise on a planet born from such ancient ingredients? If so, JJ667cc might represent a window into an alternate path for habitability, one where biochemistry unfolds without the abundance of elements like phosphorus or sulfur that Earth life depends on. The triple star dynamic adds another layer of wonder. From JJ667cc's surface, the primary sun would appear as a dim, ruby orb, while the two companions might shine like brilliant lanterns in the sky, one orange, the other pale gold, casting ever-shifting shadows across the landscape. Their gravitational interplay could stabilize the planet's axial tilt, preventing chaotic climate swings, or they might occasionally flare, bathing the world in bursts of radiation. The mysteries of this system are a reminder that habitability isn't a checkbox, it's a spectrum. JJ667cc challenges us to rethink how planets form and persist in complex stellar environments, proving that even in the most unexpected corners of the cosmos, the conditions for life might find a way. Every new observation peels back another layer, revealing not just the secrets of this world, but the boundless creativity of the universe itself. Hidden in the flickering shadows of a distant red dwarf, Kepler 1649c emerged as a revelation, a world so Earth-like it sent shockwaves through the astronomy community when discovered in 2020. Of the thousands of exoplanets identified by NASA Kepler Space Telescope, this one stands apart, not just for its size, a mere 1.06 times Earth's radius, but for the breathtaking precision of its orbit, tucked perfectly into its star's habitable zone where temperatures could allow liquid water to exist. What makes this discovery even more extraordinary? The planet was almost overlooked entirely, buried in old Kepler data, until artificial intelligence dug it out like a cosmic archaeologist uncovering lost treasure. Kepler 1649c's star is a quiet red dwarf, smaller and cooler than our Sun, but what it lacks in brilliance, it makes up for in stability. Unlike the flare-prone red dwarfs that bombard their planets with deadly radiation, this star simmers calmly, offering its Earth-sized companion a rare gift: consistency. The planet orbits every 19.5 Earth days, close enough to bask in the star's faint warmth yet far enough to avoid tidal locking, a rarity for worlds around such dim suns. Instead of one side perpetually scorched and the other frozen, Kepler 1649c might rotate just enough to distribute heat evenly, creating temperate zones where water could flow and life might gain a foothold. The role of AI in this discovery can't be overstated. As Kepler's data piled up over the years, human eyes missed subtle signs of this planet's existence, tiny dips in starlight obscured by noise. But machine learning algorithms trained to recognize the faintest whispers of planetary transits spotted the pattern. It's a watershed moment in astronomy, AI not just assisting human researchers, but leading them to breakthroughs we might never have found alone. This planet's detection hints at a future where artificial intelligence combs through cosmic data, uncovering hidden worlds at a pace humans could never match. Yet mysteries linger. Red dwarfs, even quiet ones, emit most of their light in the infrared spectrum, meaning any potential plants on Kepler 1649c would need to photosynthesize using wavelengths invisible to our eyes. Could forests here glow in deep reds and purples, their leaves adapted to harness this alien sunlight? And with an atmosphere likely richer in carbon dioxide than Earth's to compensate for the star's faintness, how would that affect weather patterns or ocean chemistry? The James Webb Space Telescope may soon provide answers, analyzing atmospheric gases for signs like oxygen or methane that could hint at biological activity. Kepler 1649c isn't just another exoplanet. It's a symbol of how much we've yet to discover. Even in data we thought we'd exhausted, its existence suggests that Earth-sized worlds in habitable zones might be far more common than we imagined, hiding in plain sight until new tools or fresh perspectives reveal them. Most thrilling of all, if this planet was nearly missed in our own cosmic backyard, what other Earth twins might still be waiting unnoticed in the vast troves of data we've already collected? The hunt is far from over. It's just getting smarter. TOI 700d isn't just another exoplanet. It's a groundbreaking discovery that proved Earth-sized worlds could thrive in the habitable zones of quiet red dwarfs. Located just over 100 light-years away in the constellation Dorado, this rocky planet was confirmed by NASA test mission in 2020, becoming the first Earth-sized world in a habitable zone detected by the telescope. But what truly sets TOI 700d apart isn't just its size. It's the tantalizing evidence that this world might cling to an atmosphere, raising the electrifying possibility of liquid water on its surface. Unlike the violent red dwarfs that dominate our catalogue of potentially habitable worlds, TOI 700 is a whisper-quiet star emitting almost no flares. That stability is a game-changer. While other planets around similar stars risk having their atmospheres stripped away by stellar tantrums, TOI 700d has likely enjoyed billions of years of calm, enough time for oceans to form, climates to stabilize, and perhaps even life to emerge. But there's a catch. This world is almost certainly tidally locked, with one side forever bathed in daylight and the other shrouded in eternal night. At first glance, that sounds like a death sentence for habitability. A planet with a scorching hot day side and a frozen night side seems inhospitable. But nature has surprises up its sleeve. Climate models suggest TOI 700d's atmosphere, if it exists, could work like a massive heat distribution system. Powerful winds might carry warmth from the day side to the night side, creating a narrow twilight zone where temperatures are just right for liquid water. Picture a world where towering storms rage along the edges of perpetual daylight, where glaciers creep into valleys warmed by air currents, or where vast underground reservoirs trap heat beneath icy surfaces. The real magic lies in the details. Recent studies using the James Webb Space Telescope have tried to peek into TOI 700d's skies, searching for traces of water vapor, carbon dioxide, or even methane. These molecules could hint at everything from active geology to potential biology. One particularly intriguing model suggests this planet might be an eyeball world, a scenario where a frozen night side stares eternally into space, while a liquid ocean glistens like a pupil on the day side, kept liquid by the star's gentle warmth. Yet mysteries remain. Does TOI 700d have enough atmospheric pressure to prevent water from boiling away in the vacuum of space? Could its hypothetical oceans be rich in salts or ammonia, lowering their freezing points and creating briny seas even in the cold? The answers might lie in future observations, but for now, this world stands as a testament to the universe's creativity. It challenges us to rethink what habitable really means, proving that even on a planet where one side never sees the stars, life might find a way to endure in the delicate balance between light and dark. What makes TOI 700d so pivotal is its role as a laboratory for alien climates. every new study refines our models, teaching us how atmospheres behave under extreme conditions. And with red dwarfs making up 75% of the stars in our galaxy, lessons learned here could apply to billions of worlds we've yet to discover. This isn't just a planet, it's a key to unlocking the secrets of the most common habitable real estate in the universe. Deep in the constellation Eridanus, 100 light-years from Earth, LP 899c quietly orbits its dim red sun, but don't let its unassuming name fool you. This super-Earth, discovered in 2022, has astronomers buzzing with excitement, and for good reason. Of the thousands of exoplanets we've catalogued, few match its combination of size, orbit, and potential for habitability. With a radius 1.3 times Earth's and a mass nearly 4 times greater, it's sturdy enough to hold onto a substantial atmosphere, yet not so massive it becomes a crushing mini-Neptune. But the real magic lies in its position, perched perfectly in its star's habitable zone, where temperatures might allow water to pool in liquid form, the elixir of life as we know it. What makes LP 899c so exceptional is its star's unusual temperament. While many red dwarfs unleash violent flares that sterilize their planets, this one is a cosmic pacifist, so calm and cool it emits barely any ultraviolet radiation. That tranquility is a game changer. Over billions of years, this steadiness could have allowed LP 899c to retain a thick atmosphere, shielding any potential oceans from the ravages of space. Models suggest surface temperatures might hover around -4°F chilly by Earth standards, but with the right mix of greenhouse gases that could rise to a balmier range. Picture a world where glaciers fringe temperate valleys, or where geothermal heat creates oases-like pockets beneath icy crusts. The anticipation around this planet is about to reach new heights. The James Webb Space Telescope has already set its sights on LP 899c, preparing to analyze starlight filtering through its atmosphere. Scientists are hunting for telltale molecules like water vapor, carbon dioxide, or even methane gases that could hint at everything from geological activity to biological processes. One particularly tantalizing scenario, LP 899c might be a Hycean world, a relatively new category of planets with hydrogen-rich atmospheres overlying vast liquid oceans. If confirmed, its alien seas could be nothing like Earth's, deeper, darker, and potentially teeming with life adapted to high-pressure, low-light conditions. Yet mysteries linger. Is this planet tidally locked, with one side forever scorched and the other frozen? Or does it rotate just enough to distribute heat more evenly? Could its thick atmosphere, if it exists, create habitable ribbons along the twilight zone between day and night? Every new observation peels back another layer of possibility, reminding us how much we have yet to learn about worlds beyond our solar system. LP 899c isn't just another dot in the cosmos, it's a beacon, illuminating the path toward answering humanity's oldest question: are we alone? The answers, when they come, might rewrite the textbooks. Kepler 1229b whispers a tantalizing possibility: an Earth-sized world cradled in the perfect orbit around its dim red sun. Nestled 870 light-years away in the constellation Cygnus, this rocky planet stands out as one of the most compelling Earth analogues we've ever discovered. What makes it so remarkable isn't just its size, just 6% larger than Earth, but its elegant dance within the habitable zone of its M-dwarf star. A single year here lasts 86 Earth days, a rhythm that places Kepler 1229b in that celestial sweet spot where temperatures might allow water to pool in liquid form. But this planet's story is more nuanced than its orbital stats suggest. While many red dwarf worlds cling to the inner edge of the habitable zone, risking runaway greenhouse effects, Kepler 1229b enjoys a more temperate position. Climate models suggest its equilibrium temperature hovers around -40°F, but with a thick enough atmosphere, greenhouse gases could trap just enough heat to push those numbers into life-friendly territory. Picture a world where carbon dioxide-rich skies act like a thermal blanket, transforming what might have been a frozen wasteland into a landscape of icy tundras giving way to temperate valleys. The challenges of studying this distant gem, however, are as vast as the interstellar void separating us. At nearly 900 light-years away, Kepler 1229b appears as little more than a shadow flickering across its star's face. Detecting biosignatures, chemical traces like oxygen or methane that might hint at life requires analyzing starlight filtered through the planet's atmosphere, a task akin to identifying the scent of a single flower in a hurricane. Current telescopes strain to glimpse even basic atmospheric components, leaving us to wonder, does this world host swirling clouds, or is its air thin and tenuous, stripped away by its star's youthful fury? Yet hope gleams on the horizon. The James Webb Space Telescope's infrared eyes could soon pierce the haze, searching for molecular fingerprints like water vapor or carbon dioxide. Even more tantalizing are the theoretical models suggesting Kepler 1229b might avoid the tidal locking that plagues many red dwarf planets. If it rotates just enough, perhaps nudged by the gravitational pull of unseen siblings, it could distribute heat more evenly than worlds with permanent day and night sides. The quiet resilience of Kepler 1229b offers a profound lesson. In a cosmos where red dwarfs outnumber stars like our Sun 10 to 1, planets like this redefine where life might thrive. They force us to confront our biases, that habitable means Earth-like, and consider that life's true cradle could be a world where the sun never rises, where photosynthesis relies on infrared whispers, or where organisms flourish beneath ice shields thick enough to crush steel. Every new discovery peels back another layer of cosmic possibility, and Kepler 1229b stands as a humble reminder. The universe writes its rules in ink we're only beginning to decipher. JJ581g stands as one of the most debated exoplanets ever discovered, a world that might not exist at all, or could be the closest thing we've found to an Earth twin outside our solar system. Orbiting a dim red dwarf star 20 light-years away in the constellation Libra, this super-Earth made headlines in 2010 when astronomers announced its detection, placing it squarely in its star's habitable zone. With a mass 3 to 4 times Earth's and a likely rocky composition, JJ581g quickly became a poster child for potentially life-friendly worlds until other researchers challenged the data, sparking a controversy that still simmers today. The heart of the debate lies in the planet's elusive signal, detected using the radial velocity method, measuring the star's subtle wobble caused by planetary tugs. JJ581g's presence hinges on interpreting noisy data buried in stellar activity. Some teams argue the signal is just artifacts of the star's own turbulence, while others insist it's unmistakably a planet. What's at stake isn't just one world's existence, but our understanding of how common habitable zone planets might be. If confirmed, JJ581g would be a game-changer, a temperate, Earth-sized world orbiting one of our nearest stellar neighbors, close enough for future telescopes to study in unprecedented detail. What makes this potential planet so tantalizing are its calculated conditions. Models suggest equilibrium temperatures around -25 degrees Fahrenheit, but with a thick atmosphere, greenhouse heating could push that into a range where liquid water flows. Its gravity, roughly 1.5 times Earth's, might help retain that critical atmosphere, while its likely tidal locking raises familiar questions. Would the eternal day side roast under the star's glow, or could air currents spread warmth to the frozen night side, creating a twilight oasis? The uncertainty hasn't stopped speculation. Some scientists have even theorized about possible climates, imagining a world where vast ice sheets creep towards steaming equatorial jungles, or where hurricane-force winds redistribute heat across the Terminator line. The drama of JJ581G transcends astronomy. It's a lesson in scientific rigor. Its disputed status forced researchers to refine detection methods, leading to more cautious claims in later exoplanet discoveries. Yet the possibility that it's real keeps hope alive. Newer studies using advanced algorithms have tentatively reaffirmed its existence, though the verdict remains far from settled. Future instruments like the extremely large telescope could finally settle the debate, either vindicating its discovery or relegating it to a cautionary tale. Beyond the controversy, JJ581G symbolizes a pivotal moment in the hunt for alien Earths. It reminded us that extraordinary claims require extraordinary evidence, and that the universe often hides its most precious secrets just beyond the edge of our certainty. Whether this world exists or not, its legacy endures, pushing astronomers to look harder, question deeper, and stay humble in the face of the cosmos mysteries. Kepler 283c drifts through the cosmos like a ghost from Earth's possible future, a world suspended in the delicate balance between hope and mystery. Located 1,700 light-years away in the constellation Lyra, this exoplanet orbits its K-type star with a rhythm eerily similar to our own, one full trip every 93 Earth days. That pace places it squarely in the habitable zone, where temperatures could allow water to flow freely across its surface. But what truly sets Kepler 283c apart is its pedigree, confirmed as rocky by density calculations, with a radius 1.8 times Earth's. It's a super-Earth built from familiar ingredients yet sculpted by alien forces. The planet's star tells a story of endurance. Kepler 283 is a K-type dwarf, smaller and cooler than our Sun, but burning with a golden stability that red dwarfs can't match. These stars are the tortoises of the cosmos, slower, steadier, and outliving Sun-like stars by tens of billions of years. For Kepler 283c, that means an almost unfathomable timeline for life to emerge if conditions ever align. Unlike the flare-prone red dwarfs that dominate exoplanet discoveries, this star's gentle glow offers its planets a rare gift: consistency. No apocalyptic radiation storms, no atmosphere-stripping tantrums, just a reliable, if dimmer, version of the sunlight we know. Yet for all its promise, this world remains stubbornly opaque to our instruments. Current detection methods reveal only the basics: size, orbit, and a rough estimate of composition. The planet's atmosphere, if it exists, could be a thick blanket of carbon dioxide nurturing a greenhouse paradise, or a wispy shroud long since blasted away by the star's youthful fury. Without transit spectroscopy data from next-generation telescopes, we're left to wonder, does Kepler 283c host towering volcanoes spewing gases to renew its air, or is it a barren rock locked in deep freeze? The greatest challenge lies in the star's quiet nature. K-dwarfs emit less light than our Sun, making their planets harder to study. When Kepler 283c passes in front of its star, the dip in brightness is infinitesimal, like spotting a fly crossing a car's headlight from miles away. And because it doesn't transit edge-on from our vantage point, key details about its atmosphere remain veiled. Future missions like the Habitable Worlds Observatory might change that, analyzing starlight filtered through its skies for molecules like water vapor or ozone. Until then, this planet lingers in the realm of tantalizing what-ifs, a reminder that some of the universe's most Earth-like worlds remain just beyond our gaze. What makes Kepler 283c so compelling isn't just its potential for habitability, it's the questions it forces us to confront. If life arose here, would it evolve at a glacial pace under that ancient sun, or explode into complexity given billions of extra years? Could a planet this size develop plate tectonics to recycle nutrients, or would its heavier gravity crush geological activity into stillness? Every unknown is a doorway to reimagining life's cosmic possibilities. For now, this distant world stands as both a beacon and a lesson. the search for Earth's twins isn't just about finding answers, it's about learning how much we have yet to see. HD 85512b dances on the razor's edge of habitability, a super-Earth whose very existence forces us to question where life might draw the line. Orbiting a K-type star 36 light-years away in the constellation Vela, this enigmatic world weighs in at 3.6 times Earth's mass, with a year that whizzes by in just 54 days. What makes this planet so captivating isn't just its size. It's the precarious balancing act it performs, skirting the inner boundary of its star's habitable zone like a tightrope walker above a furnace. The climate here hinges on a critical unknown. Does HD 85512b wear a thick atmospheric cloak, or has its air long since boiled away into space? Models suggest surface temperatures could swing wildly depending on the answer. Without an atmosphere, this world might resemble a scorched Mercury, its sunward side baked to 700 degrees Fahrenheit. But with a dense shroud of carbon dioxide, a plausible scenario for a planet this massive, everything changes. Greenhouse gases could trap just enough heat to cool the day side to a balmy 86 degrees while circulating warmth to the night side. Picture a world where sulfuric clouds drift across copper-hued skies, reflecting the star's glare like a planetary thermostat gone rogue. Debates rage over its true nature. Some astronomers argue HD 85512b's proximity to its star would trigger a runaway greenhouse effect, turning it into a Venus-like inferno. Others counter that its high gravity might foster geological activity, volcanoes replenishing the atmosphere faster than solar winds can strip it away. The planet's star adds another layer of intrigue. While K-types are calmer than red dwarfs, they still emit enough ultraviolet radiation to threaten atmospheric erosion. Yet here's the twist: HD 85512b's star is metal-rich, meaning it formed from gas laced with heavy elements that could have seeded the planet with ample minerals for cloud formation, nature's own sunscreen. The key to unraveling these mysteries lies in the next generation of telescopes. The James Webb Space Telescope has already tried peering into this world's atmosphere, searching for chemical fingerprints like ozone or carbon dioxide. Future instruments like the 30-meter telescope could go further, mapping temperature variations between its day and night sides, or even detecting surface features through sophisticated light analysis. Every new observation inches us closer to answering whether this planetary tightrope act is a death spiral or a masterpiece of cosmic equilibrium. HD 85512b isn't just another exoplanet. It's a laboratory for extreme climates, proving that habitability isn't a fixed point, it's a spectrum of possibilities, each more unexpected than the last. Kepler 296e spins through the cosmos in a celestial waltz few worlds ever experience, an Earth-sized planet orbiting not one but two stars. Located over 1,000 light-years away in the constellation Lyra, this enigmatic world dances in the habitable zone of its primary star, a dim red dwarf, while a second, fainter star pirouettes farther out in a gravitational embrace. That binary arrangement makes Kepler 296e one of the most complex and fascinating potentially habitable planets we've ever discovered. Its very existence challenges our assumptions about where life could take root, proving that even in stellar duos once thought too chaotic for stable orbits, Earth-like worlds might find a way. What makes this planet so extraordinary is its delicate balancing act. Kepler 296e completes an orbit every 34 Earth days, basking in just enough warmth from its primary star to keep water liquid if conditions align. But here's the twist: that second star, though distant, tugs subtly on the system, potentially influencing the planet's climate in ways we're only beginning to model. Unlike the dramatic twin suns of Tatooine from science fiction, this binary pair creates a more nuanced dance. The secondary star is a dim M-dwarf, so faint its light barely grazes the planet, yet its gravitational presence could stir eccentricities in Kepler 296e's orbit over millennia. Imagine a world where the habitable zone isn't a perfect circle, but a shimmering ring that flexes and shifts with the star's slow cosmic ballet. The planet's potential for liquid water hinges on a puzzle scientists are still piecing together. Red dwarfs like Kepler 296e's primary star emit most of their light as infrared radiation, a spectrum that interacts differently with water and ice than the visible light bathing Earth. Climate models suggest this could create a cold trap effect. Infrared warmth might be absorbed more efficiently by ice than liquid water, paradoxically stabilizing glaciers even in nominally temperate zones. Add the gravitational nudges from the binary companion, and the planet's climate becomes a labyrinth of feedback loops. Some simulations show Kepler 296e as a snowball world with equatorial meltwater lakes, while others paint it as a global ocean shrouded in steam. Then there's the tidal locking dilemma. Like many planets orbiting red dwarfs, Kepler 296e likely faces its star with one side forever in daylight, the other in endless night. But the binary companion might disrupt this lock just enough to create a slow rotation, where days last for years rather than being permanently fixed. Picture a world where dawn creeps across the landscape over centuries, with climates evolving as the star's glare gradually shifts from one hemisphere to another. Such a scenario could offer fleeting windows of habitability, regions where temperatures stabilize long enough for life to emerge before the inexorable turn plunges them back into ice or scorch. Studying this world is like trying to decipher a cosmic cipher. Its binary system scatters the light astronomers rely on to probe atmospheres, making it harder to detect key molecules like water vapor or carbon dioxide. Yet the James Webb Space Telescope has attempted precisely this, analyzing the subtle dimming of starlight as Kepler 296e transits its primary star. Early data hints at a hazy atmosphere, possibly rich in nitrogen or methane gases that could act as both blanket and shield against stellar flares. But the real breakthrough will come when next-generation telescopes like the Habitable Worlds Observatory peer deeper, untangling the mixed signals from this complex stellar duo. What Kepler 296e teaches us isn't just about one world. It's about rewriting the rules. Binary stars make up nearly half the systems in our galaxy, and if planets like this can thrive amidst their gravitational tides, the universe's habitable real estate just expanded dramatically. This isn't a planet that conforms to our expectations. It defies them, proving that life, if it exists, might flourish in the last places we'd think to look. Every new discovery in this binary system peels back another layer of cosmic creativity, reminding us that the universe's imagination is wilder than our own. Captain B isn't just another exoplanet, it's a cosmic survivor, a world that's endured more upheaval than most stars ever witness. Orbiting a faint red dwarf 13 light-years away, this ancient super-Earth carries the scars of a violent past. Its star, Captain Star, isn't like the Sun or even typical red dwarfs. Born in a dwarf galaxy torn apart by our Milky Way billions of years ago, it's now a rebel part of the galaxy's halo, hurtling through space at breakneck speed as one of the fastest-moving stars in the night sky. Yet against all odds, Captain B has clung to its place in the habitable zone, offering astronomers a glimpse of what life might endure in the universe's most turbulent neighborhoods. What makes this planet so extraordinary is its age. At nearly 11.5 billion years old, more than twice Earth's age, it's one of the oldest known potentially habitable worlds. When this planet formed, the universe was still in its infancy, with few heavy elements to seed rocky worlds. Yet Captain B defied the odds, emerging as a super-Earth roughly 5 times our planet's mass, with gravity strong enough to hold onto an atmosphere across eons. Its orbit lasts 48 Earth days, placing it in that rare sweet spot where liquid water could persist if other factors align. But survival here wouldn't be easy. Captain Star is a flare-prone red dwarf, bathing its planet in radiation that could strip away atmospheres over time. Yet some models suggest Captain B's hefty mass might have shielded it, its gravity pulling lost gases back like a cosmic safety net. Even more intriguing is the possibility of tidal heating. Like Jupiter's moon Io, gravitational flexing from its star could fuel volcanic activity, replenishing the atmosphere and creating hydrothermal oases where life might cling. Picture a world where continents are forged in endless eruptions, beneath skies aglow with auroras from constant stellar winds. The debates around Captain B's habitability are as fiery as its hypothetical volcanoes. Some researchers argue its star's violent youth in a devoured dwarf galaxy would have sterilized any chance of life. Others counter that 11 billion years is more than enough time for biology to adapt, perhaps even thrive in extreme conditions. If life did arise here, it would have had triple the time Earth's organisms have had to evolve, raising spine-tingling questions. Could intelligence have emerged and vanished billions of years before Earth's first microbes stirred? Might fossils lie buried beneath its ancient crust, remnants of civilizations lost to deep time? Captain B's greatest lesson isn't just about one world, it's about resilience. If planets like this can endure galactic collisions, stellar flares, and the slow erosion of cosmic time, then habitability might be far more tenacious than we ever imagined. As we search for life beyond Earth, this ancient wanderer reminds us, the universe doesn't play by our rules. Life, if it exists, writes its own story, one that might be older, stranger, and more enduring than we dare dream. Gliese 832c might be one of the most deceptive worlds we've ever found. A planet that looks like Earth's twin at first glance, but could harbor climates wilder than anything in our solar system. Orbiting a placid red dwarf just 16 light-years away in the constellation Grus, this super-Earth weighs in at 5 times our planet's mass, with a year that flies by in just 36 Earth days. Yet despite its tight orbit, it basks in the habitable zone's sweet spot thanks to its star's faint glow. The numbers paint a tantalizing picture, an Earth Similarity Index of 0.81, a score surpassed by only a handful of known exoplanets, and equilibrium temperatures that could, with the right atmosphere, support liquid water. But here's where the simplicity ends. This world's climate hinges on a paradox. Gliese 832c's hefty mass suggests it could cling to a thick atmosphere, one dense enough to distribute heat evenly despite likely being tidally locked. Yet that same atmosphere might tip the scales toward a runaway greenhouse effect, turning the planet into a Venus-like inferno. Some models predict surface temperatures swinging between -20 and 120 degrees Fahrenheit, depending on whether clouds dominate or greenhouse gases run amok. Picture a world where hurricane-force winds howl across the Terminator line, where towering storm fronts separate molten rock from frozen tundra, or where subterranean oceans churn under layers of high-pressure ice. What sets Gliese 832c apart isn't just its extremes, it's the quiet nature of its star. Unlike the flare-prone red dwarfs that bombard their planets with radiation, this star emits a steady whisper of light, offering astronomers an unusually clean signal to study. Recent observations hint at traces of water vapor in the planet's atmosphere, though whether those molecules condense into rain or steam depends on mysteries we've yet to solve. The James Webb Space Telescope could soon provide answers, analyzing infrared light for molecules like carbon dioxide or methane that would reveal whether this world leans toward temperate or torrid. Proximity amplifies the excitement. At 16 light-years, Gliese 832c sits well within the reach of future direct imaging missions. Concepts like the Habitable Worlds Observatory aim to capture actual photographs of planets this close, potentially revealing surface features, continents, ice caps, or even cloud patterns. Radio telescopes have already scanned the system for artificial signals, just in case a civilization thrives under that dim red sun. While no technosignatures have been found, the very attempt underscores how this planet blurs the line between science and imagination. The deeper lesson of Gliese 832c lies in its contradictions. A world with Earth's potential but alien mechanics, it defies easy categorization. If thick clouds dominate, it might be a global sauna where life floats in perpetual twilight. If greenhouse gases prevail, its surface could bake under crushing pressures. Or just maybe, it strikes a delicate balance, proving that super-Earths aren't just oversized versions of our world, but entirely new canvases where nature paints with bolder strokes. Every new observation peels back another layer, reminding us that the most Earth-like planets might be the ones that force us to rethink what Earth-like even means. Kepler 438b stands as both a beacon of hope and a cautionary tale in the search for Earth-like worlds. A planet so similar to ours in size and temperature, it boasts one of the highest Earth Similarity Index scores ever recorded at 0.88. Located 470 light-years away in the constellation Lyra, this rocky world orbits its red dwarf star every 35 Earth days, nestled snugly in the habitable zone where liquid water could pool on its surface. But beneath these promising numbers lies a harsh reality. Kepler 438b's sun is anything but a gentle neighbor. Unlike the placid yellow glow of our sun, this star is a cosmic tempest, unleashing violent flares with terrifying regularity, outbursts so powerful they could strip away atmospheres and sterilize surfaces in mere millennia. What makes this world so fascinating is the paradox it presents. On paper, Kepler 438b ticks nearly every box for habitability. Its radius is just 12% larger than Earth's, suggesting a familiar rocky composition. Equilibrium temperatures hover around a brisk -24°F, but with a modest greenhouse effect that could easily climb into the range where water flows. Early models even hinted at the possibility of stable climates, with atmospheric circulation patterns that might distribute heat efficiently despite the planet's likely tidal locking. For a brief moment, astronomers dared to hope they'd found Earth's mirror, until the star's true nature came crashing into focus. Observations revealed Kepler 438b's host star unleashes superflares, colossal eruptions of radiation roughly every few hundred days. These aren't the mild solar flares we occasionally experience. They're 10 times more energetic than anything our sun has ever produced. A single such event could bathe the planet in X-rays and ultraviolet light intense enough to shred molecular bonds, while the accompanying coronal mass ejections might scour away its atmosphere like sandblasting a fresco. The numbers are sobering. Calculations suggest the planet could lose an Earth's worth of atmosphere in just 200 million years, a blink in cosmic time. Yet life, if it ever emerged here, might not go quietly. Kepler 438b's high gravity, about 40% stronger than Earth's, could help it cling tenaciously to whatever atmosphere remains. Some theories suggest volcanic outgassing or comet impacts might replenish lost gases, creating a grim cycle of destruction and renewal. Organisms, if they existed, would likely retreat underground or into deep oceans, evolving shielding mechanisms akin to Earth's radiation-resistant extremophiles like Deinococcus radiodurans. Photosynthesis here would demand adaptations beyond anything on Earth, perhaps relying on infrared light filtered through thick cloud decks, or harnessing chemical energy from hydrothermal vents entirely divorced from the hostile surface. The greatest lesson Kepler 438b teaches isn't about one world's fate, it's about redefining the boundaries of habitability. This planet forces us to confront an uncomfortable truth. The Milky Way's most common stars might also be the most dangerous landlords. Red dwarfs like Kepler 438's sun outnumber stars like ours 10 to 1, yet their turbulent youth and flare-prone dispositions could render many of their otherwise perfect planets barren. But buried in that challenge is a revelation. If life could endure here against all odds, it suggests biology might flourish in environments we'd written off as hopeless. Kepler 438b isn't just a world. It's a test case for resilience, proving that habitability isn't a fixed state but a spectrum of creative survival strategies written in the DNA of whatever clings to existence under crimson skies. Future telescopes might soon settle the debate. The James Webb Space Telescope could analyze atmospheric survivors, gases like carbon dioxide or methane that hint at geological or even biological activity, while next-generation observatories listen for radio silence or scan for artificial signals. Whether Kepler 438b is a graveyard or a refuge, its story reshapes our cosmic perspective. In the end, this world reminds us that the search for life isn't just about finding planets that look like home, it's about discovering how far life can bend before it breaks. From crimson glowing worlds bathed in eternal sunset to ocean planets where water stretches deeper than our deepest trenches, these 25 alien planets reveal a cosmos far more diverse and wondrous than we ever imagined. Each one defies expectations. Kepler 186f proving Earth-sized worlds could orbit red dwarfs, Proxima Centauri be whispering of life right next door, and Hycean worlds like K218b rewriting the rules of where biology might thrive. Some, like Kepler 452b, mirror Earth so closely they feel like glimpses into alternate futures, while others, like JWST with its triple star skies, spin science fiction into reality. The quiet resilience of Ross 128b, the ancient mysteries of Captain B, and the turbulent drama of Kepler 438b, every discovery peels back another layer of cosmic possibility, proving that habitable means something far richer than we once thought. The past decade of exoplanet research has been nothing short of revolutionary. We've gone from wondering if other Earths existed to mapping worlds where rain might fall as glass, where mountains loom under triple sunsets, and where life could pulse in oceans hidden beneath miles of ice. Technologies like the James Webb Space Telescope are turning distant specks into real places, analyzing their atmospheres for the chemical whispers of biology. Projects like Breakthrough Starshot promise to send our first interstellar postcards to planets like Proxima Centauri b, while next-generation observatories will soon photograph exoplanet continents and storms. We're living through the greatest era of exploration in human history, not across oceans or continents, but across light years. Yet for all we've learned, the universe keeps surprising us. Every new planet forces us to ask bigger questions. Could life flourish without oxygen? Could intelligence arise under a star so dim plants evolved to harvest infrared? The answers might lie in the data we've already collected, waiting for a sharper algorithm or a fresh perspective to reveal them. That's the thrill of science, it's never finished. So stay curious. The next breakthrough could be days away, hiding in the flicker of a distant star or the faintest blip in a telescope's data. Hit subscribe to join us as we cover these discoveries in real time, and let us know in the comments which of these 25 worlds blew your mind the most. The cosmos is vast, strange, and far more alive with possibility than we ever dreamed, and the best chapters of this story are still being